The second type of problem we're going to look at today kind of shows us one of the ways that polynomial long division can actually be helpful. So here's my problem. I want to find out, is x minus 3 a factor of x cubed plus 4x squared plus x minus 6? And you might think, well, okay, let's just try to factor. Let's try to factor our polynomial and see what works. Okay, factoring by grouping. If I group these guys, I'd have x squared times x plus 4. Here they only have a 1 in common, plus 1 times x minus 6. Okay, that doesn't give me an x minus 3. So you might be inclined to think, well, okay, no, it's not a factor. One other way that we could figure that out, especially if we aren't able to factor this by grouping, because we won't always be able to. We won't always be able to factor this by grouping. One other way that we can check is to use long division. We want to see, does x minus 3 go into this? That means our x cubed plus 4x squared plus x minus 6 is going to go under our bar. The x minus 3 is going to go on the outside. So just like what we were doing before in our first examples, let's look at our first. X times what gives me x cubed? It's x squared. X squared times x is x cubed. X squared times negative 3. And subtract down. Our x cubed cancel out. 4x squared minus negative 3x squared gives me positive 7x squared. And x times 7x gives me 7x squared. Oh, I almost forgot. Don't forget to bring down your next term. I almost did there. 7x times x gives me 7x squared. 7x times negative 3 is negative 21x. Subtract. X squared terms cancel out. X minus negative 21x is positive 22x. Then we bring down our last term, minus 6. X times 22 gives me the 22x. 22 times negative 3 is minus 66. But I can tell right away, I'm going to have a remainder here. My x's will cancel out, but I'm going to have a remainder. I end up with remainder negative 6 plus 66, a remainder of 60. Since I have a remainder here, the answer is no, it's not a factor. One nice thing too, if you make sure that you're writing your like terms on top of each other, as soon as you get to the end of the bar, you know you're done. And that's one other trick that you can look for. You know you can't divide anymore if you're at the end of the bar. That's where we stop.